All right, here we go. So we got this is our course. I put it on along my kitchen table because I had a really strong contrast between the white tape and the table itself. So as I put this down here, we're going to watch the robot run. We go along, get to the end, and then stop. Try it again. Let's see. I'm going to put it right in the center. So he's going to go to the end and stop. I could also kind of leave it off to one side, so maybe only one photoresistor's on. It'll find its path. That'd be a little bit more wobbly. All right, so what we might notice about this is the robot is moving quite quickly. If it goes off, I guess we can kind of look at the robot itself. We look up front. We're going to see it's got two of these. I have the IR photoresistors on there. Regular photoresistors would also work, but the IR ones give just a greater difference in the values. I played around with this a little bit just to make sure that the distances were right for me to get like the right values when I'm over the table versus over the tape. So I did a bunch of testing with that, and this distance was just right for me. Let's see, we can look at if this thing is over the tape. We can get a sense of what the code is doing. If one side is over the edge, I'm having the opposite wheel turn. So if the left part is over the left photoresistor, because I'm looking face on at this, if the left one is over the tape, then the right one is going to move. If I get them both over the tape, you can see both the wheels are moving. And if I get just one of them over the tape, then just one wheel is moving. So that's really what I'm doing in my code. For me, what I did here is you can see that both wheels are turning, kind of no matter what. It's just which one is going faster. So we're going to look at my code here in a second, and you'll see in the code that there is basically just variables for fast speed, slow speed. If they're both over the white tape, then they both go fast. If only one photoresistor is over the tape, then only one of them will go fast. And that's really just all we're doing, switching back and forth between there. And with that, we get a line following robot. Let's take a look. So I kind of set it off to the edge. It's going to go all the way. Okay, so we're going to go through the code to make the line follower work. We're going to start up at the top with the variables, and hopefully a lot of this makes sense. I think these first 6 ones, well, I know these first 6 ones are all just kind of identifying pins, so I don't have to worry about later on in the code about knowing which pin is which. So these 6 are here. The top 2 are for the left motor, second 2 are for the right motor. These are for my resistors, so I'm using 2 photoresistors on mine. I'm using like IR photoresistors for mine, as you saw in the video. But I'm using 2 resistors for that, so I have 2 pins identified, so I just don't have to worry about that. In here, these are my threshold values. These are the values I'm using to decide whether the photoresistor is over the white tape or over the black table. As you know, like these values will change. Could be higher or lower depending on what your photoresistor is reading, whether it's IR or a regular photoresistor. These values are probably pretty high compared to the other ones you might use if you're using a photoresistor in the field or anywhere else. So we have to tweak these values a little bit. I did make 2 different variables for left and right. They ended up being the same, but I was just kind of cautious about seeing if there's any differences in the resistors, but they ended up being basically identical for the ones that I was using. Might not be your case though, so it could be helpful to have 2 of these. These are my other things. So these are new things that we have not maybe used before, but basically I'm just, as the name implies, I have 2 variables that are keeping track of how fast my motor should run. Whether it should be fast or slow. The reason I put these as variables was really helpful when I was like developing my line follower and adjusting my values for this particular set of motors. It was really nice to just have these as variables that I could tweak later on as we go. So we'll see maybe, and once we look into the code, we can see kind of what's going on and how these are getting used, and then why it was helpful to have them get tweaked in here. Okay, so that's all good there. Let's take a look through the other stuff in our code. I have some serial print stuff just to prove, like just to demonstrate like I was using the serial reader to figure out kind of like what variables I'm getting off of my photoresistors. Speaking of the photoresistors in here, I am collecting some values for the left brightness, the right brightness. I hope you see that like my naming is very intentional about my left and right. I want to like really have very clear names. Not just saying A, B, C, D. I'm giving some really clear names about what they are doing. So left, right, right, right. Okay, and then here, I was just printing these out because I wasn't sure, and if things were like going wrong, it was really hard to tell what was going wrong. So putting these as variables in here was very helpful. Okay, so in here I did some a little bit fancier stuff. I don't think you necessarily need to have this, but it was helpful for me. Just to make my life a little bit easier so I could focus on thinking through the line follower problem and not worry about code so much. So let's talk through what's going on here. I hope this is like kind of makes sense about what we're doing here. A bool, so basically what I'm making is a true or false statement. Left on is going to be either true or false. And same thing for right on. So we are figuring that out whether, like, when I read from left brightness, so when I read from the analog resistor, when I do the analog read from the left resistor, is that value less than the threshold that I set? And same thing for the right. I have a true and false value. If this thing is true, that means that the photoresistor is over some white tape. If it's false, it means it's not over the right tape. And same thing for the right one. So again, figuring out these values, the left threshold, right threshold, I tweak those values in here depending on what I was reading off of my photoresistor. So it was like kind of an ongoing process of figuring out kind of what were the resistors getting me, and then tweaking those values to match it. All right, so now we get into the big bulk of our code in here. And let's take a look at this. So we can see right here, actually I'm going to make this a little bit more readable. So we're going to talk about, so basically what we're looking in here is we are checking the values for our photoresistors. So let's just put this in here just to make it a little more, I condensed it, but I think this is good. All right, so maybe we can even we can separate these lines as long as they're still attached to brackets. It's going to be just fine, but I want to kind of focus on one of these at a time. So I think if you get the pattern of what I'm doing here, you could probably recreate this on your own quite quickly. But basically what I'm doing here is I'm checking to see, to begin with, if left on is true and right on is true. That means, like I said, these variables are saying these variables should be true when they're over the white tape. So what this tells me is if these are both true, then I should be driving forward and I should be applying fast speed to both of them. So basically, it doesn't really matter what fast speed is as long as it's the same for both, because that should, in theory, make the robot drive straight. Generally, it's good to have faster speed on this. You see my speed is at like 0.7. I should talk about my speed code too as well. But let's just look at this. So I set like 0.7, so that's almost like 70% of its maximum speed. I could probably tweak this higher or lower, but I found like kind of going relatively fast was helpful for this rather than trying to go really slow. So left drive, right drive, fast, super fast. So before we move on, let's look down to left drive, right drive. We've talked about this before, but just to be really clear about kind of what's going on here. What I did was, and I think I gave you this code already for those of you who saw it in class. It's up in the OneNote, and I'll attach the code in here as well. But basically, just as a reminder of what this is doing, or if you don't know what it's doing, it's taking in a value between -1 and 1, and then it's converting it into power for our individual pins on the motors. So what that means is this allows us to do something like left drive, where we're passing in a value between -1 and 1, rather than previously we had to pass in a value of or had to use a value of between 0 and 255, and then we're doing some subtraction or stuff. This hopefully simplifies everything quite a bit, so that's just -1 to 1. If we pass in 1, it's going to make the motors go full speed forward. If we go back actually up top here, you can see this. If you haven't added this to your code already, if you haven't done the right drive, left drive thing, you can comment this out, and it should make both the motors drive forward at full speed. You could test this. If it doesn't work, if one goes backwards, then you probably have to switch some pins. You could switch the pins either up here to control left and right differently, and maybe control them in reverse. You could also flip the pins on the board, but do one or the other while you're testing. Yeah, if it's going backwards. So if it's your first time using the drive, you could test with this if you have not seen it before. Okay, so yeah, so again, they're taking a value between -1 and 1, and they're going to set their respective motors left and right to a power, to a power based on what values you pass in there. If you want, you can look through the math thing a little bit more and try and make sense of it, but that's what I did. All right, going ahead back into this, we can... so we can see in here. So if left drive is on, right drive is on, that means we're going to go left full speed, right full speed. On the other hand, if left is on, so that means left is over the tape, and then right is false, that means right's not over the tape. If you think about that with our robot, that means that the left part of the robot is starting to kind of go off to the right of the tape. So that means we need to really turn back left. So that's why I indicated here that we're turning left. In order to turn left, we're going to make the left motor go a little bit slower, and we're going to make the right motor go a little bit faster. I've put this value pretty low on the left side. You could totally tweak these values up and down. I found 0.2 is probably the slowest I could make the motors go and then still turn, and even then they wouldn't always turn consistently. So yeah, if it's going off to if it's detecting on the left but not on the right, we're going off to the right side of the tape, and we need to turn back to the left. On the other hand, if it's the reverse, left is off, right is on, then that means we need to turn back more towards the right. Okay, and then finally, I just said in here, there's some other fancier things I could do here, but I basically said, like, if both the wheels go off, then we should do slow speed to kind of catch our way back onto it. I thought that would work. Just didn't really come up for me. I could maybe do negative fast speed in here, might be better. There's also a more fancier way that we could do this, but that should be enough for now. So hopefully that was helpful, and I'll see you soon.